This is Algebra 1, Homework 7-4 Solutions. I want to make a clear statement at the very beginning of this that the way that I solve it isn't the only way to solve it. There are many ways to solve it. Some of them might be more efficient than the way that I'll solve it. So just keep that in mind as I'm going through these problems. In number 1, I have some parentheses, and that's where my eyes are drawn to first. The reason that my eyes are drawn there is because, I'll write up here, PEMDAS, please excuse my dear Aunt Sally. I'm first looking, is there any sort of parentheses that I can simplify? Well, inside of that parentheses, unfortunately, no, you cannot simplify anything in here. So I'm forced to do my exponent, this power of 4, and distribute that to both the base of the x and to the 2. So this is now going to be 2 to the power of 4, x to the power of, okay, and I'm going to skip a step here, but I'm going to say it out loud. I have a -1 to the power of 4. So it's a power to a power. That means I'm multiplying. -1 times 4 is -4. And then I'm going to rewrite times 2x to the power of 4. So from here, I'm going to multiply the 2, I guess I'll do 2 to the power of 4. You could also do this a second way. You could say that's 2 to the power of 1 and then add the exponents. I'm going to do it the longer way, the way that I think most students would solve this. 2 to the power of 4 is the same thing as 2 times 2 times 2 times 2. 2 times 2 is 4. 2 times 2 is 4, and 4 times 4 is 16. So this is going to be 16x to the power of, and now I can simplify just a little bit because I have x to the power of -4, x to the power of +4. When I have multiplication with those same bases, I'm going to add these exponents because I'm multiplying. Adding -4 plus 4 is 0, so it's x to the power of 0, and then I'm still going to be multiplying by the 2. This 2 drops down here. From here, anything to the power of 0, namely this x, is going to be 1. So I'm going to cross that off and say it turns into a 1, and 16 times 1 is 16, so it's the equivalent of just kind of scribbling out that term. 16 times 2 is 32. 32 for my final answer, which I'll then check. 32 for number 1. Number 1 is just 32. How about number 2? In number 2, again, I'm drawn towards looking at the parentheses and seeing, can I simplify anything in there? Unfortunately, no, which means I'm forced to distribute 4 into the x, 4 into the 2. Again, you're distributing it into the bases and applying the power. So it's going to be 2 to the power of 4, x to the power of, again, I'm going to multiply -1 times 4. Is this the same problem? Oh my gosh, it looks very similar. The only difference is that 4 changed into a 2. But it's going to be the same thing as we did last time. This is going to be to the power of -4 because we multiply -1 times 4. And then I'm going to rewrite this times 2x to the power of now 2 instead of 4. So from here, I know that 2 to the power of 4 is 16 from the last problem. This is still, it was x to the power of -4, but same bases mean we add. I'm going to add -4 plus 2, and that's going to add up to -2. -2, and then I'm going to multiply the 2 still. We do my 16 times 2, which is 32. And this x to the power of -2, remember the negative power is only being attached to the x. It's not attaching to that 16. The 16 and the 2 are left in the top. But this x to the power of -2 is going to be brought to the denominator. And this is now going to be over x, not to the -2 anymore, but +2. And I get my final answer. 32 over x squared for number 2. 32 over x squared for number 2. And number 3, I don't see any parentheses, so I'm not drawn to that. I am drawn to the fact that there's a multiplication sign, which means I'm going to multiply the 2 and 3, and I'm going to add the exponents 3 and -4. Uh-oh, Riley just woke up. As I was saying in number 3, the first thing that I'm seeing is our multiplication symbol. The 2 and the 3 are going to be multiplied first. So I'm going to leave the top alone. This is going to be x to the power of -1. In the denominator, I'm multiplying the 2 and the 3 to get a 6. And then I'm going to multiply x cubed by x to the -4. When I'm multiplying these same bases, I'm going to add their exponents. I have a 3 and a -4, which adds to a -1. This will turn into x to the power of -1. So there's 2 ways of thinking about this, but the easiest way of explaining this is if you see the same thing, the exact same thing in the top and the bottom, the negative and the 1, negative and the 1 for the power, these 2 terms are exactly the same. You can cross cancel them, cross and cross, and whenever you have nothing left in the top, you assume that that nothing is a 1. So it's going to be 1 over 6 for my final answer, which I'll then box. Let's check number 3. The answer is 1/6. 1/6. And moving on to number 4. In number 4, again, I kind of see the same thing where the denominator has multiplication happening. I can simplify the denominator. I'm kind of simplifying both sides of the fraction. The top of the fraction cannot be simplified, but the bottom of the fraction can. So I'm going to rewrite the top. I can't do anything. 2n to the power of 3. The denominator here, I can multiply the coefficients. 2 times 2 is going to be 4. And I'm going to multiply n squared times n cubed. Because I'm multiplying something with the same base, I'm going to do the shortcut and add these exponents, 2 plus 3 to get 5. This is going to be n to the power of 5. The denominator is a little bit more simplified, but the only problem now is I have to simplify this fraction. So the first thing that I'm seeing with the fraction are the coefficients, 2/4. I can divide both the numerator by 2 and divide the denominator by 2, and I can get 1/2. Now I need to decide where to put my n's. Notice that the power for the n in the denominator is larger than the power in the numerator. That means I want to put my answer in the denominator. I usually put my answer wherever the answer is most positive. It's most positive with the 5, so I'm going to write my n down in the denominator. And then I'm always going to do if it was in the bottom, I'm going to do bottom minus top. This n is in the bottom, so I'm going to do 5 minus 3. But if I had put the n in the top, I would have done top minus bottom. But now I'm going to do bottom minus top. So the bottom minus the top is 5 minus 3, and 5 minus 3 is 2. And I get my final answer. Let's go ahead and check our work. 1 over 2n squared for number 4. 1 over 2n squared for number 4. I'm moving on to number 5. Oh, nice. I see a power of 0. That's where my eyes are drawn to first. I'll deal with the parentheses here in a sec. Maybe some people will see the parentheses first, but unfortunately, with the parentheses, there's nothing on the inside of the parentheses that I can simplify. I'm simply going to have to distribute this 2 into each base. There's only one base, so I'm distributing it just once. So I'm going to do power here, power here. Let's see what that looks like. Anything to the power of 0 is 1, which again is the equivalent of just scribbling that all out and just saying there's only a 2 in the top. So in the top, I just have 2. In the denominator, I'm going to distribute the 2 into this base, and I'm going to have x to the power of negative 3 to the power of 2. Power to a power just means I multiply. Negative 3 times 2 is negative 6, so I'm going to have x to the negative 6. This is basically done. The only problem is I have a negative exponent. Whenever you have a negative exponent, the base underneath it and everything that was in the power, this whole thing is going to switch sides. If it's on the bottom, it goes to the top. If it was on the top, it would go to the bottom. So I'm going to show my work by saying this is going to come to the top, and it's going to be 2x, not to the negative 6 anymore, but to the positive 6. What is left over on the denominator? Nothing. I mean, it's just a 1, so you can write the over 1, but it's not simplified, so I'm just going to leave it as 2x to the power of 6 and call that good. Let's check our work for number 5. 2x to the power of 6. 2x to the power of 6. We're on a roll. Let's work on number 6. So again, I'm first drawn to the parentheses. There's nothing inside the parentheses that I can simplify, which means I'm now forced to distribute the 3, and there's no really distribution that is needed. You're just doing a power to a power. Power to a power is multiplication, and this is going to be r to the power of 2 times 3. 2 times 3 is 6. Numerator has not moved. It's still 2r, and technically, this power above the r is 1, which I'm going to write in right here, just in case people forget it. All right, now I need to decide where to put my r. I can't have 2 r's. I can only have 1 in my final answer. Notice that the r in the denominator has a higher exponent than the one in the numerator. So that means my answer is going to be in the denominator. And I'm going to do, because my answer is in the denominator, I'm going to do denominator minus numerator, 6 minus 1, to get r to the power of 5. What about that 2? The 2 didn't have any power. Well, technically it was a power of 1. It was not allowed to move anywhere, so it's still stuck in the numerator. It's still 2 over r to the power of 5. And there's my final answer, which I'll box. Let's check our work for number 6. 2 over r to the power of 5, 2 over r to the power of 5. Then we're moving on to number 7. In number 7, I'm drawn to parentheses. There's nothing on the inside of the parentheses that I can simplify, so that's going to mean I'm going to distribute the 2 into both the n and the 2, meaning that the numerator is going to stay the same. Let's deal with the numerator in a sec. We can simplify that a little bit. But in the denominator, I have 2 squared and n to the power of what? Well, I have a power to a power, so I'm going to be multiplying. Negative 1 times 2 is a negative 2. In the numerator, I can simplify because I have the same base that I am multiplying. So I can add these exponents. You always add when you have multiplication with the same bases. So I'm going to get n to the power of negative 1 plus 3 is 2. And don't forget about this coefficient of 2. Usually the coefficients we write out front. All right, so from here, I'm looking right here, and it's not quite ready to be simplified, so maybe I'll do that in the next step. I'll go ahead and say, I know that 2 squared in the denominator is really 4. The numerator, I'm going to leave that the same, and from here, I can only write 1n if I choose, and I'm going to do that, notice that the numerator has a higher exponent than the denominator, or it's more positive, I should say. So I'm going to put my answer in the numerator. And then I'm going to do top minus bottom because my answer is in the top. If my answer is in the bottom, my variable is in the bottom, I would do bottom minus top. But I'm doing top minus bottom because we're up here. So it's going to be 2, then minus this negative 2. And I'll write that down again. 2 minus a negative 2, because I know a lot of students might make a mistake on here. You have to do a subtraction, and you have to just rewrite this so you have a double negative. When negatives kiss, they become positive, and now I can also simplify my 2 over 4 by dividing the top by 2 and the bottom by 2. So my final answer here is going to be 1 in the numerator, which I'll probably erase in a sec, n to the power of 4 all over 2. And typically speaking, when we have a coefficient in front of our variable that's 1, we don't write that. So I'm going to go here and use my eraser tool and erase the 1 and call it good. N to the power of 4 over 2 for number 7. N to the power of 4 over 2 for number 7. Then we move on to number 8. In number 8, again, my eyes are first drawn to the parentheses. Unfortunately, can't simplify anything. Can we ever simplify anything? It looks like we're never going to be able to. No, it doesn't look like that. So I keep saying that over and over again, but it's not going to happen for the rest of these problems, so I'm going to stop saying that. But I usually do look there first. I am going to look at the the denominator still first, and I'm seeing that I'm going to be multiplying these two numbers because I have a power to a power. A negative 3 times a negative 2, well, negative times a negative is a positive, and 3 times 2 is 6, so this is going to be x to the power of 6. In the numerator, what do we have happening? Well, notice I have a multiplication symbol with the same bases, x and x, which means I add the exponents, negative 1 plus 2. Negative 1 plus 2 is 1, so I'm just going to get x to the power of 1. Don't forget to write the coefficient. This 2 is going to come out front, and we have 2x to the power of 1. All right, I can only have one type of variable in the problem. I can't have two x's. So I have to choose where is it going to live, top or bottom, and the answer, as you probably have seen by now, is going to be the bottom because I have the higher exponent in the bottom. So that means the only thing that's left over in the top is the 2. The x is going to live in the bottom, and I'm going to do bottom minus top, 6 minus 1 to get 5, and that's my final answer. 2 over x to the power of 5 for number 8. Number 8, 2 over x to the power of 5. Moving on to number 9. In number 9, we finally have a mix of variables, x's and y's. I'm only going to have one x and one y in my final answer. I don't know if it's in the top or the bottom, but I'm only going to have one of them. So the first thing that I see again is parentheses, and I'm going to be distributing this negative 4. I'm going to do this with pen, so I'm showing my work. This negative 4 is going to go to all 3 of these bases. I'm going to rewrite that. So numerator is not going to change, 2y to the negative 1. The denominator is going to be kind of big. It's going to be 2 to the negative 4, x to the, okay, let's be careful here. I'm going to have a power to a power. That means multiply. 4 times negative 4 is negative 16. And then I'm going to have y to the power of, and then again, I'm going to have negative 3 times a negative 4. Negative 3 times a negative 4 is a positive 12. And then I still need to rewrite all of this x to the negative 1, y squared, x to the negative 1, y squared. All right, running out of room, coming down here to the next line. I am going to simplify the denominator because I have an x and an x, a y and a y. Those can be simplified. Since they're all technically being multiplied, you don't have a symbol for multiplication when they're all squished together. I'm just going to add their exponents, negative 16 and 1, and then I'm going to add the exponents, 12 and 2 for the y's. This 2 to the negative 4 is still going to be left down there. We'll work with you later. 2 to the negative 4, and then x to the power of, let's go ahead and add, negative 16 plus negative 1 is negative 17. Then I have the y's. I have 12 plus 2, which is going to be 14, so it's y to the power of 14. The numerator is still unchanged, 2y to the power of negative 1. From here, every single base that has a negative x, or sorry, not that one, this base, and this base, these 3 bases have a negative exponent. So these 3 terms are going to switch. And I'm going to do that in pen so you can see my work. This y to the negative 1 is going to come to the denominator. This x to the negative 17 is going to come to the numerator. This 2 to the negative 4 is going to come to the numerator. And then all those powers will be positive. Notice I did not circle this 2 because this 2 is technically to the power of 1, which is positive. Positive powers do not switch sides. So from here, I have that 2 left over in the top. I have another 2 to the power of now positive 4, an x to the power of positive 17. There's the entire numerator. The denominator, I originally had a y to the power of 14, and I moved down a y to the power of 1. From here, I can simplify a little bit. If you remember our problem number 1, 2 to the power of 4 is 16, and 16, here, let me write that down so that we remember. This number right here is 16, and 16 times 2 is 32. So let me come over here and say this is going to be 32x to the power of 17, and the denominator, because I have the same base and multiplication happening, I'm going to add 14 plus 1 and get 15, so y to the power of 15. That 5 can be rewritten a little bit nicer. There we go. There's my final answer, 32x to the power of 17 over y to the power of 15. Let's check our work. 32x to the power of 17 over y to the 15. Did I get that right? 17 and 15? I did. Okay, it just didn't sound familiar for whatever reason, but I did get it right. Then we move on to number 10. In number 10, I'm going to multiply, meant to not double click there. I see the 3 and negative 2, which I'm going to be multiplying, and I'm going to get an m to the power of negative 6. I'm going to rewrite everything else, times 2 n to the power of 3, all over n m to the power of 3. This n is technically to the power of 1, so I'm going to write that in as well. All right, I see a negative power, so this entire, and I'll do this in pen, this entire m to the negative 6 is going to come to the denominator, and now my new problem will look like this. 2n to the power of 3, all over m to the positive 6, n to the 1, m to the 3. All right, I have no more negative powers, so from here, I'm just going to try to simplify as much as I can. This 2 is not going to move. I can only have one n, and notice I have two n's right here. Well, between these two n's, the bigger exponent is in the numerator, so my final answer is going to have the n in the numerator, and I'm going to do top minus bottom since my answer is in the top. You start with that side. So top minus bottom, 3 minus 1 is 2. Notice I have two m's, m and m. Because they're both in the same side, they're both in the denominator, I'm going to add 6 and 3. 6 and 3 add to 9, so it's going to be m to the power of 9, and there's our final answer, 2n squared over m to the 9. 2n squared over m to the 9 is indeed correct. Moving on to number 11. Number 11, I can simplify both the numerator and denominator right now, just a little bit. So in the numerator, I can only have one a. I have an a squared and this a to the negative 2. Because these are the same base, I can add their exponents due to the multiplication. 2 plus negative 2 is the same thing as 2 minus 2, and 2 minus 2 is 0. So I'll have a to the power of 0. You know where I'm heading with that in a sec, but for now I'm going to write it like that. What about my b's? I only have one b, and it's to the negative 3. So I'm just going to recopy you down over here. What about our c's? I have two of them. They're both to the power of 3. I'm just adding their exponents. This is c to the power of 3 plus 3, or c to the power of 6. Now, for the denominator, I'm just going to distribute the negative 1 into both of these two bases, and it's going to essentially just change the sign of their exponents. Instead of being a to the negative 4, it's now a to the positive 4. The c used to be to the positive 4, and now it's the negative 4. All right, we've gotten this a little bit simpler. Again, I can only have one a, but check this out. This a to the power of 0 is going to go to 1, which is, again, the equivalent of just scribbling it all out, and I only have one a in the denominator. I can only have one b, and I have it, but the problem is it's a negative, so I'm going to go ahead and switch the side. I'm going to say this b to the negative 3, I'm going to bring to the denominator, and I can only have one c, and I have two of them. Which one is the more positive of the two? Well, this one, so my answer is going to be in the top. Let's go ahead and give my fraction, I'm going to do it down here. My fraction is going to have a c in the top. In fact, there's only going to be one thing in the top. This is not going to be a very big fraction. It's going to be c, and then I'm going to write this out so people can see. It's going to be top minus bottom, and the bottom is negative 4. So there is a double negative in this case. I do have a b to the power of 3 in the denominator. It is a positive 3 because it switched sides, and I still have this a to the power of 4. From here, I can simplify the numerator's exponent, which is going to be c to the power of negatives kiss, that become positive. 6 plus 4 is 10. So this is c to the power of 10 over a to the power of 4, b to the power of 3. And I did try to make this alphabetical. Typically speaking, when you have a bunch of variables all squished together, you go alphabetical. A does come before b, but it's not incorrect if you said b cubed and then a to the power of 4. But I'm pretty sure the answer key will agree with me. C to the power of 10 over a to the power of 4, b to the power of 3. Oh, the answer key doesn't agree. I mean, we got the right answer. I should circle it. We got the right answer, but it didn't do it alphabetically, which is a little bit surreal to me, but we did get the right answer. All right, in number 12, I see a lot of parentheses in the denominator. Let's go ahead and distribute this 4 into all 3 of these bases and do the same thing with the 2 to all 3 of these bases. So from here, the numerator is going to stay the same. This is going to be an x cubed y squared. In the denominator, I'm going to have y to the power of 4, x to the power of, okay, remember what's happening here. We're multiplying because we have a power to a power. 4 times 4 is 16. And we're going to have z to the power of negative 3 times 4, which is negative 12. Okay, that was the first bit. Now I'm going to do all of this bit over here. 2 is going to go up there, so it's going to be a 2 squared. Oops, didn't mean to do that. 2 squared. Moving to the right a little bit, I have y to the power of, again, this is a power to a power, so we're multiplying. 2 times 4 is 8, and this is going to be z to the power of, and then again, this is 4 times 2, so it's going to be 8. Notice that I'm writing my z's with a little line through them, so that way you can distinguish them between my 2's. I highly suggest you do that as well, unless you want to accidentally get points taken away. I'm usually pretty good about distinguishing your handwriting, though. All right, that denominator can be simplified because I have multiple y terms, multiple z terms. Those can all be combined. And I can go ahead and get that 2 squared into a 4. So this denominator, what is it going to look like? Well, let's go ahead and write the coefficient first. Typically, coefficients are first. So 2 squared is 4. Then let's go ahead and collect all the y terms. So for the y terms, I have a power of 4 and a power of 8. Again, because of the multiplication that's happening with these, I am going to be adding these. 8 plus 4 is 12. This is going to be y to the power of 12. What about x? It should go x, then y, then z, but whatever. X is going to be the power of, well, there's no other x's. There's one x here and no other x's over here, so I'm just going to recopy down 16. What about our z's? There are multiple z's here, so I have to add all of their exponents together because of the multiplication that's happening. We have negative 12 plus 8, and that's going to add to negative 4. I'm going to recopy down the numerator. That hasn't changed. It's still x cubed y squared. All right. And I'm going to do a bunch of things all at the same time, and I'll hopefully get my final answer. The first thing that I'm going to do is I'm going to rewrite my fraction and leave that 4 in the denominator. So the next thing I'm seeing is this x cubed isn't the only x. There's one x here and another x here, which means I need to choose a side. Pick your lane, right? When you're driving a car, pick your lane, man. So this exponent is larger, so my answer is going to live down in the denominator. I'm going to have x right here, and then I'm going to do bottom minus top. 16 minus 3 is 13. And then I'm looking next at my y's. I have 2 of those. Again, my denominator has a higher exponent, so I'm going to leave my answer in the denominator. And I'm going to do bottom minus top. 12 minus 2 is 10. And then finally, this z to the negative 4 has a negative power, so I'm going to bring this negative 4 up to the, or this z to the negative 4 up to the numerator and make it a positive 4. And I think I've got everything dealt with. That should be the final answer. Let's go ahead and check number 12. Z to the power of 4 over 4x to the power of 13, y to the power of 10. Z to the power of 4 over 4, y to the 10, x to the 13. It's not alphabetical. It's annoying. It goes x, y, z. Whatever. We'll give it to you. Y to the power of 10, x to the power of 13. Making sure I got that right. I did get it right. That concludes the homework 7-4 for Algebra 1. Thank you for watching.